leadership. It's something that's like some conference or open house. Not quite sure what it is.
Sure.
But I need to be there for school.
No problem. Just I'll try to keep track of it, but if I forget, you holler when you need to leave.
All right.
Okay. Are these problems you can verbalize? Like, can you, your polynomial?
They're on the book. They're on the book, the whole unit.
All right. So we need to go to that. Is that big ideas?
Yeah.
All right. Let's see. And log in. The algebra. And which chapter? 7?
Chapter 7, yes.
Which part?
Part 7.3, I believe.
Multiplying polynomials?
Yeah. Mm-hmm.
Okay.
And that's what I want to practice.
Okay. Let me get down to the exercises here. All right. Let's have a look. Have they taught you something called FOIL?
No.
Okay. That's good. I don't like FOIL anyway.
Yeah, my teacher briefly mentioned it. She was saying sometimes you'll hear the acronym FOIL, but on some polynomials they will not work.
That's right. That's right. FOIL only works when you have 2 terms times 2 terms. If you have 2 terms times 3 terms, it's not going to work. What I prefer better than FOIL is ET. Every term times every term. Pretty simple, actually. In other words, you want to take this term and multiply it by that. You want to take that term and multiply it by that. You want to take this term and multiply it by that, and you want to take that term and multiply it by that, and you want to add them all together. So that's what I mean by ET. Pretty straightforward. Every single term needs to multiply by every other term.
All right.
So, what's the first thing we get? What's x times x?
X squared?
All
right.
And I have found that it's quite useful to always go in the same order. In other words, go from left to right. Start with your first term and multiply it by every other term. Not the same term, not this minus 2, but multiply it by every term in the other expression. And do all problems that way. In other words, work your way from left to right. So what's the next term?
The next one would be x times 2, which is 2x.
Okay, and we need the sign because we need to know whether we're adding or subtracting it. And what's next?
Negative 2 times x.
And finally,
negative 4.
simplify.
And then simplified, it's x squared plus, no, x squared minus 4. All right.
Now, notice one thing here, and I might be getting a little ahead, but you're going to get to this at some point. that right there is called the difference of perfect squares. Can you see why it's called that?
No.
Well, x squared is a perfect square, 4 is a perfect square, and we're taking the difference between them.
Oh, all right.
When you have the difference of perfect squares like this, it always factors into two terms that only differ by the sign that's in the middle. In other words, x minus 2 times x plus 2. Okay?
Sweet.
If I were to start out with x squared minus 9, that's also the difference of perfect squares. That is going to factor into x minus 3 times x plus 3.
Okay.
Okay? If I had 4x squared minus 9, that's also the difference of perfect squares. That's going to factor into 2x minus 3 times 2x plus 3.
All right.
That's the way difference of perfect squares works. Now, granted, we are starting with the beginning. In other words, multiplying two binomials together. So that's a little bit advanced. Let's look at number 4, which is not difference of perfect squares factored. But we're going to be able to use our every term by every term. Okay, what's the first term? Equal to?
Would it be negative 2x squared?
Huh? Next term?
X plus x.
We're multiplying here, remember. Ah, plus x, yes. Excuse me. You have the right answer. Okay. Next term?
And then 6x
Plus 6x. Okay.
plus 6x. And then minus 3.
Okay. Simplify.
Simplify, that would make it negative 2x squared plus 7x minus 3.
All right. All right. Let's go down here and find some more. Now let's make sure you have a good knowledge of these before we get to harder ones. I think you do. Do this one real quick for me.
X squared plus 3x plus 1x, which is just x, plus 4, and
Plus 3.
no, sorry, I forgot we were multiplying.
It's all right.
And that equals x squared plus 4x plus 2.
All right. Let's see if we can find some tougher ones here. 11. A little bit different.
All right.
3m plus 1. And all of these are binomials. In other words, we're multiplying two terms by two terms. So what's this one?
3m squared plus 18m.
Multiplying.
Wouldn't that be 18m?
3 times 9?
Is, oh, sorry, 27.
Okay.
And then m plus 9.
All right. Okay. Let's do 12. 2p minus 4 times 3p plus 2.
Six p squared.
Uh-huh.
Right. Plus 4p.
Okay.
Minus 12p.
Okay.
Plus, no, minus 8.
Okay. Simplify.
6p squared minus 8p minus 8.
Uh-huh. Notice that whenever we simplify, this term doesn't change and that term doesn't change. The only thing we're doing is combining the inside terms. Let me make one up for you that's a little harder here. Okay. Now we have a binomial times a trinomial. This has got 3 terms in it. So it's the same rule. FOIL wouldn't work here, but ET works just fine.
Alright. So, would that be a cubed
Yeah,
number?
you add whenever you're multiplying. In other words, when I have 2p times 3p squared, multiply the numbers, multiply the variables. This has an implied 1, so when you're multiplying, you add the exponents. So 6p cubed. What's next?
6p cubed, and then it would be, sorry, 3p? Wait, no, 2p squared.
There you go.
Alright, plus 2p squared.
Huh?
And then plus 4p.
Okay.
Then it would be negative 12p squared. Plus, no, minus 4p. Minus 8.
Good. And always follow that methodology. In other words, start from left to right and do all of those, and then do all of those. And now, again, when we're simplifying, notice that this isn't, there's only going to be that many p cubes, and there's only going to be this many numbers. So you don't really need to search around for any other p cubes. So we got that. And how many p squareds do we have?
Negative 10.
And how about p?
There would be 0p.
Okay.
And then you just minus 8.
And that's really all there is to it. When you're multiplying binomials or trinomials, or even if I had a trinomial times a trinomial, just start from left to right and multiply every single term.
Alright.
Why does it say use a table to find the product?
Oh, there are these things called algebra tiles,
Oh,
which is, I don't really like them.
yeah, I don't either.
It's kind of,
That's what these
like
are? Okay.
Yeah.
No, to me they confuse the issue. It's a simple enough thing to do. Here's a FOIL method, yeah, okay. Write two binomials whose product includes the term 12. Number 32.
All right.
Whose
Could be
product? In other words, we don't want 12 in the binomials, but we want a 12 somewhere in the answer.
all right. So maybe 3x plus 2 plus.
Not plus, times.
Oh, sorry. Times.
That's what
6.
That's what product means. Is the product means two things multiplied or three things multiplied.
Times 6x plus 4.
Well, let's do that. Multiply this out. What's the first term?
It would be 18x squared.
Okay.
Then the second term would be plus 12x.
Okay.
And then, oh, I see where I went wrong.
Okay, so how do we guarantee we're going to end up with a 12? Remember, the first term and the last term don't change.
So you can make it like 3x by 4x or 2 times 6.
Okay, usually each of these terms has one variable and one number. This is a binomial term, but we wouldn't want to say 3x plus 2x.
Oh no, I meant like put 3x in one pair of parentheses and 4x in another pair.
Okay. Write two binomials. That wouldn't be two binomials. If I were to,
So if you replace,
if I were to do this,
so if you were,
that results in 12, but it doesn't. It's not two binomials.
I just kind of meant like replace 6x with 4.
Okay, there you go. If I replace that with a 4, we're guaranteed to have a 12 in the answer. Because the very first term we get is 12x squared. And we know that's going to be the only x squared that we have. The other thing I could have done was made that a 3 instead of a 2, because I know that 3 times 4 is going to end up at the end, and that's the only number we're going to have.
Yeah.
All right. The soccer field in this picture is rectangular. Write a polynomial that represents the area of the soccer field.
Well, you would have to multiply the two polynomials on the label. So
Missing one? Ah, I was missing one. My x minus 30 was covered up in my picture.
oh,
That's funny.
I have it.
Yeah,
pulled
I'm
up on
seeing
another
it now, but
page.
for a second there was a note over it or something. So what's the area going to be?
Well, in factored form, so I know that, it would be the quantity 6x plus 10 times the quantity, x plus 10, not 6x, multiplied by x minus 30.
All right. Do that for me?
Yeah. X squared plus negative 30x.
Hold on. Let me back up here. I got a little ahead of myself here. Write a polynomial that, okay, let's do that. X squared, go ahead. Minus 30x.
So,
what's next?
Minus 30x plus 10x minus 300.
Okay, simplify.
It would be x squared minus 20x minus 300.
Okay. This is the polynomial that they're looking for part A. You were correct that to say that that's in factored form. And there's nothing wrong with that, but they wanted us to go ahead and multiply it out. Okay, now when x is 90, let's find the area of the field. Now let me just show you something. Are you familiar with the f of x notation? Have you ever seen it?
Yeah.
Okay.
I think we were working on that before.
Okay, well, what we have is a polynomial that represents the area of the field. And I'm going to say that that is a function. And furthermore, when I use f of x notation, I'm saying it is a function of x. So the area of the field is a function of x, which is equal to x squared minus 20x minus 300. Well, now they want to know what is the area when x equals 90. Well, that's the same as this notation. What is f of 90? That's what that means, is that whatever is inside the parentheses, we're going to substitute in for x. So what would f of 90 be?
90 squared minus 20 times 90 minus 300.
It's that number.
All right.
Is that what? Can you do that in your head?
I don't think so.
Actually, it's not hard to do in your head if you do that part first. What is that part equal to?
That part is equal to, negative 15, no, not negative, negative 2100.
Okay, now do you see why it's easy to do if you do that part first?
Yeah.
What's 8100 minus 2100?
7200?
No.
No.
There's the 2100. 81 minus 21 is 60. So 6,000. Not that, these little tricks are not something that it's important for you to learn. It really isn't. The only reason I mention them is sometimes it's helpful. You don't have to pull out the calculator. But that's the way I do these without a calculator. Is I look for parts that are going to be easy. I can see that that's going to be 2100, and 2100 subtracts from 8100 really easily, as opposed to if this was 2200. Then it's not so easy to do in your head. Subtracting 22 from 81 is not nearly as easy as subtracting 21 from 81. If it was actually 2200 here, I probably would have used a calculator. So, the area of the field when x is 90 is 6,000 what? Feet? Yards? Miles? Square feet? Square yards?
It would be square yards, right?
Square yards, yeah. Whenever you're dealing with two dimensions, which is what area is, it's not three, it's just two, you're always going to be dealing in square units. Whereas if I said, what is the length of this soccer field, the answer would be 100 yards, not square yards, but yards. Yards is a linear measurement. It's a measurement of one dimension. Square yards is a measurement of two dimensions. Cubic yards is a measurement of three dimensions. In other words, if we were talking about the volume of a rectangular brick, we'd be talking about cubic something. All right, so we have a area of 6,000 square yards, And question C says a groundskeeper mows 200 square yards in 3 minutes. How long does it take the groundskeeper to mow the yard?
It would take, well, if it is 6,000 square yards,
Okay.
you would divide 6,000 by 200, and then multiply that, no, and then divide that by 3.
Multiply that by 3. Actually, let's talk about this. Intuitively, you knew that you needed to divide that by 200, which gives you 30, which means that he has to take 3 minutes 30 times. So it would take him 90 minutes to mow the yard. Okay? But let's look at it a different way. Whenever we're doing problems like this, we can use conversion factors. All
right.
Well, I want to teach you this. This is a little complicated. Let's say he could mow 200 square yards per minute. Okay? So the question is, do I multiply this or do I divide it? Well, if it's 200 square yards per minute, and we want our answer to be in minutes, the conversion factor needs to be reversed. I need to put the 1 minute on top, the 200 square yards on the bottom, right?
Yeah.
In other words, because we're trying to get rid of yards, and we want our answer to be in minutes. So if he could do 200 square yards per minute, that's 1 minute per 200 square yards also. Now I know I have to multiply that conversion factor because the square yards will disappear and I'll end up with minutes.
All right.
Now in this problem he can do 200 square yards in 3 minutes. So the conversion factor is 3 minutes per 200 square yards. The key is to always get these conversion factors correct in the numerator and the denominator. Even though this particular problem, you're smart enough to know intuitively that you needed to divide 6,000 by 200. And you're also smart enough to know you wanted to multiply that by 3. But when you look at the units, the advantage of looking at the units is it guarantees you're doing it right. If I look at it like this, and I know my answer is supposed to be in minutes, then I know I've done it correct. That goes away, I end up with the minutes, and I have to divide 6,000 by 200 and multiply all of that by 3, so I still get my 90 minutes. But whenever you're doing conversions like this, sometimes they'll be a lot more complicated. There'll be 3 or 4 factors. And the way to get the answers is to always make sure you have your units in the proper, whether it should be in the numerator or the denominator, you want them to be in the right spot. You know what I'm saying?
Yeah. Yeah.
All right.
All right.
All right.
So,
well,
hand off here?
Yeah, that's a good place to stop.
All right.
Have a good week. I'll talk to you next week at 4:30.
Thank you.
All right. Bye-bye, David.